Swayam Prabha. Digital India. Educated India.
As it is rightly said by Albert Einstein, I am not specially gifted or clever. I am only very, very curious. It is curiosity, the main factor that drives physics and lets us to discover new things and new opportunities. Today, I, Rishi,
And I, Arnav Goyal, are going to show what is inertia.
with the help of some experiments and illustrations. Inertia is present in our surrounding. It surrounds us and it connects us. You might, or in fact you have, experienced inertia in your day-to-day life. For example, when when sudden brakes are applied, you tend to fall forward. This happens because of inertia. While the bus has stopped, your body stays in motion and wants to stay in motion. For this reason, you tend to fall forwards. Inertia is used in our day-to-day life, from space travel to transportation, from timekeeping, etc. It is vital in our day-to-day life. My friend Anna will explain with the help of some examples.
As my colleague said, that inertia is there in our day-to-day life. I'll be giving some examples. Like in transportation, when big ships reach the port, they turn off their engines to save oil as they have inertia which can get them to the port. Second example is that when spacecrafts, when they leave the space, due to the neglection of air friction and they turn off their engines and they are in vacuum, so they still move.
Now I will demonstrate inertia of rest with the help of an example. A dangerous one, in fact. These are some books and a hammer. Now the books have inertia because they have higher mass. Now I will try to hit my hand. Now enough. Can you make some observations what will happen after the experiment?
Your hand will be swollen.
Okay. Now we will see the experiment. My hand is fine. Why did that happen?
Because of the inertia of rest.
The object had inertia. For these reasons, they had enough inertia to resist the hammer's force. For this reason, my hand is fine.
Now I am going to show inertia of motion. As we have a container filled with rocks and a fidget spinner. As we release them in the same time, the fidget spinner goes there first. Why is that? Because of inertia of motion. This is filled with rocks, so it is more heavier than this fidget spinner. And the fidget spinner is lighter, so it has less inertia, as inertia is directly proportional to mass. And now we have another illustration. If we put paper and then fidget spinner, if we take it out, it stayed there. But why is that? Because of inertia of rest. But if we try that same thing on a piece of cardboard which is less in height, it shouldn't do that. Despite of having less potential energy as it is mgh, the height is less, but because of inertia of rest, it happens still. Now my colleague will show you another example.
Now I will show you inertia of motion with the help of Maxwell's wheel. Maxwell's wheel were invented by theoretical physicist Maxwell. This wheel works on the principle of inertia of motion. Now, enough. What do you think will happen when I will release this wheel?
It will go there. It will just stay there.
How many times do you think it will come back up and down?
5 times.
5 times. Now imagine if there was no resistance and friction within the rope. How many times do you think it will go?
It will go there for unlimited loops.
Why?
Because there is no force opposing it.
Because it has inertia of motion. It will tend to stay in motion in the same direction. This happens because of inertia of motion.
And now I will show another example. Now if I pull this cloth, the books will stay there because of inertia of rest. But if I pull the cloth slowly, then the books will move with it. Why is that? Because of inertia of rest.
Now I will show another experiment showing inertia, but in a different way. Here inertia will help in the net force. Now, when I will rotate this, the box will contain centripetal force, while at the same time, this fidget spinner's case would have inertia. The force of inertia would be enough to counteract the centripetal force. For this reason, this case will not move. As you can clearly see, it didn't move at all. This happens because the box is experiencing many forces: gravity, friction, and centripetal force. But all of these cancel out because it has inertia. The more the mass, more the inertia. Thank you.